Yesterday we had discussed about the mechanism involved in release of hydrogen type. Today we will be talking on the mechanism mechanism involved in absorption of oxygen type. As I have told you earlier, depending on the nature of your environment, actually anion and cations prefers to react, and we have also discussed that environment may be of three types: acidic, basic and neutral. If your environment is acidic, release of hydrogen type mechanism will follow, and if it is neutral or basic, then absorption of oxygen type mechanism will follow. To absorption of O2 type, your environment is neutral or alkali. Here I would like to tell you, if your environment is alkaline, what does it mean? It means right from the beginning there are some anions in your environment, and therefore once the cations are formed, reaction will automatically start. But if your environment is neutral, in that situation we have to create both anions and cations, and therefore the example we are going to take today, we'll do it assuming that your environment is neutral, so that we learn how both anions and cations are generated in this system. Now let it be the area where we would like to make the infrastructure made of iron. I have discussed it yesterday itself. Your environment is neutral, I have told you. This is the metallic structure made of iron, we know that. Now, as I have told you, if you are, this job is actually specifically for civil engineers. If they are actually intelligent and honest, they will go with due protection. But unfortunately, if we do not take protection, what will happen? We will be talking on that only. So if we do not go with the protection, because which will involve huge amount of investment. So in this situation, what will happen? Now that this metallic structure made of iron will come in contact with environmental gases, and most importantly, oxygen will come in contact with iron, as a result of which oxide layer will be produced from the metal surface, which we have discussed earlier also. And this will be your ferrous oxide. We also know that ferrous oxide is porous in nature. It means there will be crack on the metallic surface, as a result of which, suppose there is a crack, this is the crack. Now you see there are some two distinct areas. A small area where there is no actually oxide layer due to the crack, and rest part is having your oxide layer, and therefore this cracked area will become your anode, and rest part will become your, try to understand this. I repeat, once a metallic structure is made and kept in an environment without any precautions, so first of all, environmental gases will come in contact with your metallic structure, and most importantly, oxygen will come in contact. And automatically, as we know that, here if it is made of iron, it is going to make an oxide layer of ferrous oxide. We know ferrous oxide is porous in nature, and therefore there will be some cracks. If we consider the crack, it means there is no oxide layer, and therefore there are two distinct areas. One area is that area where there is no crack, and rest part is having your oxide layer, and therefore the cracked area will become your anode, and remaining part will become your cathode. As I have told you earlier, there will be actually 5 different areas, distinct area. Number 1 is this one. Number 2 will be anodic area. Number 3 will be cathodic area. Then we have to go with anodic reaction and followed by cathodic reaction. Now, at anode, what will take place? As we know, iron is a metal. There is no crack. Sorry, there is a crack. And therefore, iron atom is exposed here to the environment. And therefore, automatically, iron will lose 2 electrons to produce Fe2+. Now, these 2 electrons will move here and there on the metallic surface. And the area where they will be moving will be cathodic area, because you see, the small area, that is cracked area, is your anode. Large area is coated with the metal oxide, and therefore, wherever the electron goes, it will be your cathodic area. One thing I have forgotten to tell you, your environment is neutral, no doubt about this. It means there is no H plus and OH minus and as such. But other than H plus and OH minus, there will be some gases definitely which will affect the fate of this corrosion. And if I ask you, can you suggest me what are the important gases that will be affecting the rate of corrosion? Definitely it will be oxygen and moisture, as we all of us know that. Like this. So, as a result of which, now what will happen? This electron at cathode, that is your cathodic reaction, twice E plus half of oxygen plus water, and this will react to produce 2H minus. Try to understand that. I repeat, at anode, iron will lose 2 electrons to produce Fe2 plus. At cathode, the electron being lost due to oxidation is roaming over the metallic surface. That is in the cathodic area, where this electron will be captured by half of oxygen in presence of water to produce 2 hydroxyl group as a result of hydroxyl ion. As a result of which, now what will happen? Try to understand that. Fe2 plus cations plus 2OH minus, it will produce FeOH whole bracket 2. Now, if sufficient oxygen is available, it will be further oxidized too. How it will oxidize? 4 molecules of FeOH whole 2 plus 2 molecules of water plus oxygen. It will be further oxidized to FeOH whole bracket 3. And this corresponds to Fe2O3, 1 molecule of water. This is what is known as yellow rust. Try to understand that. And if oxygen is limited, FeOH whole bracket, if it is not further oxidized, then it will correspond to Fe3O4, and this is known as your black anhydrous magnetite. Black anhydrous magnetite. Try to understand. I repeat, once cations and anions are formed, they will come closer, as a result of which ferrous hydroxide will be produced. If sufficient oxygen is available, it will be further oxidized to according to this reaction. 4 molecules of ferrous hydroxide, 2 molecules of water, and 1 molecule of oxygen to produce ferric hydroxide, which corresponds to Fe2O3, 1 molecule of water. This is your yellow rust. But if sufficient oxygen is not available, oxygen supply is restricted, then FeOH whole bracket 2 will correspond to Fe3O4. It is known as black anhydrous magnetite. Before I go further, I would like to tell you what we have seen. You have made a metallic structure made of iron. You have kept it on an environment without any protection. Oxygen will come in contact. Oxide layer will be formed. Ferrous oxide being porous, there will be crack on the metallic surface. Now the metal structure will have 2 distinct area. One area, a small area, where oxide layer is not there due to crack, and rest of the part will have oxide layer. Now this cracked area will become your anode, and rest part will become your cathode. That anode, iron will lose 2 electrons to produce Fe2 plus. Now those electrons will move on the metallic surface, metallic structure. that is definitely your cathodic area, because cathodic area is very large. Now at cathode, both the electron will be captured by half of oxygen in presence of water to produce 2H minus. Now this Fe2 plus and OH minus will be attracted by each other to produce ferrous hydroxide. Now this ferrous hydroxide will be further oxidized to ferric hydroxide, which corresponds to yellow rust. If oxygen supply is limited, then Fe2 will correspond to Fe3O4, which is also known as black anhydrous magnetite. The most important features, as we have seen yesterday also, there are 4 different features. You have seen your anode is the cracked area, a very small area, and rest of the part is your cathodic area, and therefore in this situation anode is very small, cathode is very large, just opposite what we have seen yesterday. Number 2, where there will be anodic area? Wherever there is a crack. If there are 10 cracks on the total metallic structure, so then 10 anodic area will be developed, and therefore in this case there may be more than one anodic area. Number 3, try to understand. Your cathodic area is very large. What happens at cathode? Absorption of electron. So demand for electron will be very, very high. But your anodic area being very small, if it wants to balance the supply and demand, so it has to supply more electron by undergoing more corrosion, and therefore rate of corrosion here will be very, very high. Just opposite what we have seen yesterday. And number 4, anodic area is very small, cathodic area is very large. But we know that corrosion occurs at anode. Where is the anode? The cracked area. We know the exact location, and therefore we can claim that corrosion will take place only at anode, a particular point, particular locality where there is no crack. And therefore this type of mechanism is also known as localized type of mechanism. Try to understand that. In case of hydrogen evolution type, the corrosion could have actually developed all over the metallic surface, because the entire metallic surface was your anode. But in this case, anode will be the particular area where there is a crack. And therefore, wherever there is a crack, we know the exact location where is the crack. And therefore, you can tell that this is the area where corrosion will take place. Exact location is known to us, and therefore it is known as localized type of corrosion. This is all about your actually mechanism involved in absorption of oxygen type. Before I finish today's lecture, I would like to repeat in short. We have developed a metallic structure. We have kept it in the environment without any precautions. Now environmental gases will come in contact. Oxygen will be abundant. Oxide layer will be formed. If the metallic structure is made of iron, oxide layer will ferrous oxide. Since ferrous oxide is porous, pores will be there, cracks will be there. Now you have 2 distinct areas. In one part there is oxide layer, in another part there is a crack, no oxide layer. And the area where there is no oxide layer will become your anode, rest part will become cathode. At anode, oxidation will take place by losing 2 electrons. Now these 2 electrons will move on the metallic surface, that is the larger cathodic area. Since your environment is neutral, there will be oxygen and moisture in the environment. So in the cathodic area, those 2 electrons will be captured by atomic oxygen in presence of water to produce OH minus. Now Fe2 plus and 2OH minus will react together to produce ferrous hydroxide. If oxygen supply is limited, it will be rearranged at Fe3O4. But if oxygen is sufficient, it will be further oxidized to FeOH(3), which corresponds to yellow rust. 4 important features I have told you. Anodic area is very small and cathodic area is very large. Number 2, we have seen anode will be the area where crack will be there. And therefore, if there are 10 cracks on the metallic surface, there will be 10 anodic area. And therefore, here more than 1 anodic area will be there. And number 3, as I have told you, oxidation takes place at anode. Electron supply will be done by anode, and cathodic area being very large, demand for electron will be very, very high, which will be actually fulfilled by supply of electron by a small anode, which is possible if the anodic part undergoes corrosion at a faster rate, and therefore rate of corrosion will be very, very high. And as I have told you, corrosion takes place at anode only, and exactly we know the cracked area where corrosion will take place, and therefore this mechanism is also known as localized type of mechanism. I firmly believe you might have understood everything. Even then, go through the video very carefully. If there is any doubt, note it down. We'll be clearing your doubts in the